All right, hey guys, we are on the last day of 1-2. I know it feels like it's been dragging on, but it's a huge vocab. It kind of sets the stage of the things that we're going to talk about. So I really want to take our time and make sure you understand each part of it as it helps describe any of the functions in the future. One thing we've already put in front of you, I know you talked about in Algebra 2, was horizontal and vertical asymptotes. And what happens here is we start approaching some line. So if it's horizontal, right, we know that's y equals from the old adage, hoi. All right, and if it's vertical, we know it should be an x equals because of our vertical lines with vux, V-U-X, okay? All right, so here's what we're working with. What I tried to do to help you out with this is you found the link, it's up here somewhere, right? It's not there yet because I'm doing the video now. But also put in all the graphs that you're gonna deal with today. So if the picture doesn't come through, doesn't look clear enough, click on that link. I have it set up as shareable, so you should be able to see exactly what's going on. So the first one we're going to deal with is x divided by 5. Well, we already know that based on domain items, x can't be 0. Okay, so that tells me something about what's going on right here as we look at the split on this graph. Okay, so we already know that x equals 0 is going to be a vertical, it's a horizontal asymptote, right, an HA. But it also seems that we have something vertically going on as well. Right? Because there must be a reason that this branch here stopped going there and picked up here. So we also have a vertical asymptote at x equals 0. All right, so that reminds me that this one needs to be y. All right, so if you already fixed that, thank you. All right, I'll get it straightened out, right? Hoi and vux, there we go. Horizontal, y equals 0. All right, there we go. Now, it doesn't mean they're always going to be 2. We'd have to take a look at the graph, right? This is an exponential equation. So we're going to see what's going to happen here. But it looks like it has this +1 on it. And we're used to some of these translations. This +1 truly has moved it up, because right? Typically your exponentials won't cross the x-axis. But in this case, we have this horizontal line. It goes through y, so horizontal asymptote, and that's going to be y equals 1. Now, if I continue with my exponentials, and this is why I put this Desmos on the side, is you can take a look at the table, and it's going to continue to grow. It just won't look like it's going very far to the right, but it's never going to be stopped by a vertical asymptote. It just becomes a lot taller, a lot faster, and that's the nature of those exponential equations. All right, in our last one, we have all sorts of cut-ups and jives and all sorts of stuff happening here. We have x over x squared. So if that means anything to you, that just means that we don't have that horizontal asymptote, but I do have some verticals, and it's based on what's going on here in the denominator. Remember, these are domain restrictions when we look at vertical asymptotes. All right, so how am I going to find it? That's going to be some x values. So if you needed to find it, we would actually be doing this. We need the square root of 5. So we know that's plus or minus the square root of 5. And all we're really looking at is it's some number right in here. Okay, so I'm going to leave it as plus or minus the square root of 5 because it is more accurate, but it's not just 2. I can see that it crosses over -2 and +2, but it's somewhere in that ballpark. Okay, so plus or minus the square root of 5. So given the equation and the graph, we can kind of work with those together. Okay, even though we're just supposed to look at the graph, I just want to make sure you can work with the equation as well. All right, so that's our horizontal and vertical asymptotes. The next thing we want to talk about is the end behavior. What happens on the very end of a graph? So we have the left, and it looks like this thing, it's increasing, but it doesn't look like it's going to cross over, right? It looks like if we're talking about above here, we had some asymptotes. Looks like it may have the same thing happening, and this is going by 2's. So it looks like we're going to approach where y equals 3. Well, what that means to my graph is my end behavior on both on the left. Okay, so as I approach negative infinity, so on the left, we're going to go to y equals 3. And on the right, we're also going to go to y equals 3. All right, that's what's happening on the end of my graph. On the second one, notice we took the square off of it. So it gave us more of a continuous here. I guess they're both continuous. But it just gave us this switch over from the positives to negatives, because obviously with the squared, everything's going to be positive. So as we take a look at this one, it looks like on the left, what's going to happen is we're going to approach 0. So the end behavior is approaching 0. On the right, we're approaching 0 again because it's coming down. So typically end behavior, you're starting to think, hey, I want to talk about this as up, up versus up, down versus down, up. But what we find out is we can actually be, in last one's down, down. What we can find out is we're actually just going to approach some number. And that's the first thing that we had. So I want to start with those. The other half, not all the end behavior approaches a horizontal asymptote. Okay, so now this is what we're used to. Okay, so we notice on the left-hand side, this is going down. And the right-hand side, this is going up. Notice I moved the scale way out. So each one of these large blocks is 10. So this one we describe as down and then up. Versus the next one, right? I see this is going up and this is going up. So I would call it up, up. Okay. Now in Algebra 2, we started to talk about limit notation. So we're always going to start with a general idea, down, up, down, whatever it is. And then we're going to describe what happens. Okay, so we're talking about the limit as x approaches negative infinity. What's that mean? That means left. As it approaches positive infinity, that means right. Okay, so this is just written in a code. And if we have a horizontal asymptote, we're talking about f of x, which is just the y value, as it approaches a number. Okay, so that means if I scroll up here, okay, so that means I can write these, looking very formal. Limit as x approaches negative infinity. That means the function approaches 3. And the limit as x approaches positive infinity, the function approaches 3. Okay, so you can see how this is going to repeat for the one on the right here. This time the function is going to approach 0. When is that going to happen? It's going to happen when x approaches negative infinity. And I could rewrite the same thing. The limit as x approaches positive infinity, the function approaches 0. All right, this gets a little bit different when we start to look at this idea of up and down. Okay, so you have to remember that down, up was the correct answer. So the limit, how do I say to the left? X approaches negative infinity. The function approaches negative infinity. Okay, so that was the second half. Is we can also say that it's going to go to positive or negative infinity as we work with it. And then to say up, we're talking about the limit as x approaches infinity. Remember, that's code for right. Then the function approaches infinity. All right, so our last one here, it is up and up, right? So we want to make sure we understand the idea in general terms and then change it to this limit notation. As x approaches negative infinity, the function approaches infinity. The limit as x approaches positive infinity, the function approaches infinity again, right? So negative infinity meaning left, positive infinity meaning right, and then we talk about the function, positive infinity meaning up, and positive infinity meaning up. Okay, so it's a little bit of a code, as long as you have the right idea. So for the sake of making sure we're on the same page, please start with the general terms. That way I can tell that you understand the idea, and then we'll circle back and fix the limit notation as needed. All right, pretty okay. All right, I'm going to ask you to do 81 way down here, but you know, I just want to kind of walk you through one of them to get started because they're kind of tricky, right? That's why it's listed as a group activity because there's a little more thought involved. So you kind of read through the whole thing. We just want to make a sketch of a graph that fits all of this criteria because we've talked about a lot of different things. So what you want to do is go through it and find the things that are absolutely necessary. So a horizontal asymptote at y equals 1. Okay, well, that's absolutely necessary. So we've taken care of that. And a vertical one at 0. Okay. All right, here's where it gets a little bit weird. I see a couple things happening where x is 0. When x is 0, I should get 0. So that should be on here, which seems a little bit odd because we have this horizontal asymptote. But here's what's going to happen is they also told me that it's non-removable. Okay, so that means somewhere else I have a hole in my graph. Okay, so that means it's non-removable because there's a hole, I just displaced it. It's not completely removed. So I've taken care of D and I've taken care of B. Now the last thing we have to understand is the function is decreasing on negative infinity until 0. Okay. So from negative infinity, which is far off to the left, until 0, I want to make sure I'm showing that this thing goes down. And it's also decreasing from 0 to infinity. So that's why I chose to put this hole way up here, because I want to show that I started here and now I'm decreasing. So I'm going to show this branch is also going to decrease. Right. Now it looks like they both start to level out, but we get the idea. If we went and played with the tables over in Desmos, right? So in case you haven't done that before, if I just add in this table, so we know that at -1 it's undefined, and notice as we go further and further to the right, this graph gets closer and closer. So you could pick a number and drop it in here. Maybe I don't want 2, maybe I want 200, and just notice how it gets smaller versus 250.02. Let's try 300. Right? We're getting so close to it, but we're never going to hit that number. So even if I put in 1,000, because it has that horizontal asymptote. So I just want to try and build some of those ideas. This is a very challenging activity. So if you struggle with it, that's a good thing, and then we'll have a chance to talk about it.